Welcome to HB Tuner's Ford Gen 1 Coyote Training Part 32. This training module, we're going to take a look at our diagnostic programming capabilities in our calibration files, as well as taking a look at some miscellaneous parameters that we haven't covered yet in other training modules. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at programming our diagnostic type of capabilities in our Gen 1 Coyote applications. Towards the end of the video, we're going to be covering some miscellaneous programming details that we haven't discussed yet in our other training tutorials in our course so far. So we're going to cover a whole bunch of different topics here in this tutorial. We're just lumping up essentially things that we haven't talked about yet in our training course in just a one video. So we're going to consolidate a bunch of things. So the first thing I want to discuss here is going to be our diagnostic capability that we have for programming within our calibration files. So if you've deleted something from your car, let's say you're taking out the cats or you're taking out something maybe in the evap purge system, and you're getting a check engine light for that, for your racing car that you're, again, not driving on public roads, you're just going to be doing racing environment, and you're not going to have to worry about emissions testing, we want to be able to turn off that check engine light. We don't want it on because if we do get a fault from another sensor that may be going bad, let's say our crank sensor starts to go bad, we want the PCM to be able to throw the check engine light for a relevant code that's actually going to be real. So we need to go and learn how we can start to program some of this diagnostic type of capabilities. So first thing we want to do here is jump in. Let's take a look at a stock calibration file. I have a 2014 Mustang GT file open here. This is a manual file. It doesn't really matter which file you have open. What we're going to find in the programming capabilities is essentially going to be the same across a variety of different calibration files. So I'm going to jump in here to our engine diag tab. This is where we can program our diagnostic capabilities within our VCM editor software. So we have a general tab, we have an airflow tab, we have a misfire tab, we have an exhaust tab, and we have a DTC tab. Let's jump in here to general. Let's first talk about this particular tab and all the parameters that we can program in here. The general tab is going to allow us to set thresholds for particular sensors. So if we fall outside the sensor range or the voltage range we could expect for that sensor, it can fault and throw a check engine light for that particular circuit. So for example here, variable cam, it's going to say that it's going to start its testing at the engine coolant temperature of 18 degrees. That's pretty cold, so we're specifying a threshold where it starts the checksum for the VCT timing. We're not going to change that. Typically, we don't need to do anything with that. And most everything on this page we can leave alone, but just understand what this stuff means. So under temp sensors, we're going to find we have our ambient air temperature sensor, an intake air temp sensor, and then down here we have a rear differential temp sensor that would be mounted in the rear diff. We'll find that we establish here the minimum and maximum voltages for that particular circuit. So if the voltage drops below 0.2 in this particular ambient air temp circuit, or in this case 4.93 if it goes above that voltage, that means we have a low or a high voltage type of situation, a circuit, it needs to throw a check engine light for that. So we can see here that it's going to give us the ability to program thresholds here. Now taking a look, we also have checksums to look for things like our engine coolant temp sensor or the intake air temp sensor. So these are going to be in either enable or disable. We'll find the Gen 1 Coyotes have a cylinder head temp sensor, but not an engine coolant temp sensor. We can find the engine coolant temp sensor is disabled. Really don't change anything in our general tab here, but we can get access to a couple different parameters that we can program. We take a look down here, we find our manifold charge temp sensor. We see that's not used on a Gen 1 Coyote application. This is used on some Roush applications, some Roush calibration files, and I believe it's used on the GT500 as well, if I remember correctly. But we'll find it's not used on our Gen 1 Coyote application. So nothing in this tab that I need to really worry about for probably 99.99% of the cars that you're going to be coming across. Let's jump into airflow. In airflow here, there are a few things that we may want to consider to change. Now, specifically, if we take a look here at our high fail 80 counts, this is going to be for the mass airflow sensors. So there's a low fail or a high fail. What this is saying is taking a look at these analog digital counts that we would reference in terms of the mass airflow sensor range of operation. The mass airflow sensor is going to range between 0 to 1,024 80 counts. Now, we talked about 80 counts when we were referencing our throttle position when we were looking at our, I believe it was the driver demand table. We jump back in here to engine and we jump back into torque management, driver demand. We'll find under the normal, we have our accelerator pedal position here. This is referencing 80 counts in terms of our accel pedal position. So the analog digital counts is an old old parameter, old language in the Ford programming that does reference the scale of a particular sensor's range in this analog digital count. So the Excel pedal sensor here, for example, moves between 0 to 100%. We can conceptually understand that. The unit scale is actually between 0 to 600 in the accelerator pedal position AD counts. So that's how it's going to look at that 0 to 100% movement range of the Excel pedal and translate that to AD counts. So it's the same kind of idea here. Let's close this out and jump back in. That's the same idea here as our mass airflow AD counts. Now, if you're pushing a lot of power through your map or through your engine, you're finding you're flowing a lot of air, it is possible to trip this upper limit, this AD count limit, which will throw the mass airflow sensor into a failed mode. In this case, you'd have to raise this up here. Now, the maximum limit is 1,024.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.